Hi everyone, so this is the video for 8.2 and this is on polar form of complex numbers. So for this we're changing back and forth in between polar and rectangular form. So rectangular form would just be like the regular form of complex numbers, like the a plus bi, which could be graphed on a rectangular coordinate. Polar form is when it would have cosines and sines with it. We also call that the trig form of a complex number. Okay, so the formula is r times the cosine of theta plus the sine of theta, and r is, another word for it is the modulus, but it's like the radius, and the argument is theta, which is the angle, and we put that between 0 and 360. So the abbreviation of this, we write it as CIS instead of writing the cosine and the sine and the theta twice. So cosine plus I sine of theta. So I like to write it like this way because it's shorter. So you'll see that a lot. So the relationships between the rectangular form or the complex number form and the trig form or the polar form. So xy is the rectangular and r and theta are the polar form, would be found by doing these things, which is pretty much everything we already know. So don't forget that it's more formulas, but if you go back to our definitions of sine and cosine, with r being like the radius of the unit circle, this is where everything comes from. Like tangent was y over x because that's opposite and adjacent. R is the Pythagorean theorem, so the radius is the Pythagorean theorem. So everything here is what we already know about, like the basic definitions of trig. So it's all kind of the same. So when we graph polar numbers or complex numbers on a coordinate plane, so this is graphing it on a rectangular plane. We're going to graph on polar planes in 8.5. Our y-axis is the imaginary axis, and the x-axis is the real axis. So when we have this is our x part and this is the y part. So the way we would graph the number 2 plus 3i would be over 2 on the real part and up 3 on the y part. So we graph these like vectors. You might have done vectors in one of your science classes. We don't do them in this class anymore. We used to. But it's like the same thing. So it's graphed like a directed line segment. We just don't put an arrow on it. So that would be this segment. And this one would be -4 plus I. So it would land right here. So it says to graph their sum. So remember from 8.1, their sum would be, you add the real parts and you add the imaginary parts. So this would be -2 plus 4i. So their sum would be -2 on the real part, 4 on the imaginary. So this line would be a representation of the sum of those two complex numbers. We're not going to do much with the graphing, but you just got to remember that x is real and the y is what is the imaginary. So the main thing we're going to learn in this section is how to convert back and forth between polar form and rectangular form. So this would be polar form and this is rectangular form. Okay, so we're going to use those formulas that were on the front to find the other ones. So here we're in rectangular, so we need polar. So, excuse me, we need to find r and theta. So one way to look at these is to think of what it would look like on the graph, which is why we're talking about the graph. But our real part is 0 and our imaginary part is -3i, so that would be down here. So we can find theta using tangent, like the formula said on the front, or we just know that that's a quadrantal angle, so our theta is going to be equal to 270. Which is why we would want to graph them. And then we need to find r. So remember, it's the square root of a squared plus b squared, or x squared plus y squared, whatever. Like this is your x and y, or your a and b. So we have 0 squared plus -3 squared. So 0 plus 9 is 9, and the square root of that is just going to be 3. So our r is 3, our theta was 270. Now we just have to put it in this form. I'm going to use the CIS form because we don't have much room. So it's r CIS theta. Well, actually, I'm going to write it out. JK. So it'd be 3 cosine So 270 plus 3I sine 270. So we plugged in our R and our theta. Oh, I distributed the R in your form on the front. It's not distributed. So the other way to write this would be 3 CIS 270, which is why I like to use that way. Okay, so let's take a look at the one down here, because that's converting to polar form as well. So we need to find R and theta. I like to graph them because then you can see the special right triangle angles, and then you don't even have to use the tangent sometimes. So our real is positive and our imaginary is negative, so that's going to put us in quadrant 4. So we go over 8 and down 4. So I don't know if you see it, but this would be 1, or no, it wouldn't be, JK. So if we look at it in terms of tangent, that's why it said that theta is equal to opposite over adjacent. So then we can find theta using the inverse. The graphing, it does help you see like opposite, adjacent, and then you can know x, y, and stuff. So if you do tangent inverse of -4 divided by 8, we end up with -26. But remember, it's in quadrant 4, so if we add 360 to get the positive coterminal angle, we get 333.43 degrees. So unfortunately for this one, it's not one of our special angle measures. Sometimes it's not. So now let's find R. So it would be the square root of 8 squared plus -4 squared. So 64 plus 16 is the square root of 80, which we can reduce to 4 root 5. Okay, so we found our theta, we found our R. Now we'll plug them in. So it would be 4 root 5 CIS 333.430 degrees. Awesome. So let's do one more of those together. Let's do the one up over here in the top corner, because why not? So let's draw a picture. So our real part this time is negative, so we'll go over -3, and then we have +1. So now this one, unlike that other one, is one of our special right triangles. So -1 root 3, or -root 3, 1, that makes that 2. So what reference angle is across from 30? Or, sorry, what's across from 1 is 30. So that means our reference angle is 30, but in quadrant 2, we're going to have a degree measure of 150. And again, you could have done that by doing tangent of theta equals opposites over adjacent, and you would end up with the same thing. I like when you guys draw the pictures, though, better. So now we need to find R. So -root 3 squared plus 1 squared. I know I'm writing this out, but we already know that R is going to be 2. So that'd be root 3 plus 1, which is 2. So plug it into the CIS form, and you'd have 2 CIS 150 degrees. So all in all, this is pretty much exactly what we've been doing for a long time. We're just writing it in a different way. And we're starting with something different, because I used to, in chapter 2, I would give this to you as like an ordered pair, -3, 1, and we would do the same thing. Okay. So why don't you go ahead and pause and try the 2 at the bottom down here, and then I will show you how to go backwards and start with CIS and turn that into the A plus BI. So go ahead and pause and do these 2 right now. I know you haven't paused it. Pause it. Okay, so if we take a look at those 2 at the bottom, this one was another quadrantal angle. We got 180. And then the one over here ended up being a hot mess with a bunch of decimals. We couldn't reduce this, so that was just it. Sometimes that'll happen. Make sure you put your degree sign. Okay, so let's talk about how to go the other direction. So if we start with this polar form, with the cosine I sine, how do we change it to rectangular? Well, this one I think is a lot easier than the other way, or maybe more straightforward. You just have to take the cosine and sine of 135 and then distribute the 10. So the cosine of 135, well, I'm going to draw my picture for 135 down here. This is 135. Our reference angle is 45. So we have 1, negative 1, root 2. So what's the cosine of that picture? Would be negative root 2 over 2 plus I. And then the sine of the picture, root 2 over 2. Don't forget the I that's there with the sign. So then we would just distribute, and since we have a 2 in the bottom, it's like halving that 10. So our final answer would be negative 5 root 2 plus 5I root 2. And that is it. So that is the rectangular version that we got from that polar version. Great, so let's try another one. So we're doing the same thing here. I'm going to start by finding the cosine and sine of 300. So I'm going to draw my picture. 300 ends up being quadrant 4 with a reference angle of 60. So across from 60 we have root 3. And it'll be negative because it's location. So that's our 1 and our 2. So the cosine of that is 1/2. And the sine of that would be negative root 3 over 2. You distribute the 2. 2 times 1/2 is 1. 2 times that, the 2 is going to cancel, so we would just have negative I root 3. So, let's do that again. So it would be 1 minus I root 3. And that's it. Okay, so the last one that we have is the same way as the ones we just did, except 115 is not our perfect angle. So you know you're going to end up timesing 6 times the cosine plus 6 times the sine. So what I do is I just type it all straight in my calculator. So 6 times the cosine of 115, we get our decimal. So it would be negative, I'm going to write it sideways actually. So that's negative 6 cosine 150 plus, it's a negative 2.5357 plus, so 6 sine 115. 5.4378 plus 5.4378I. So that would be it. So if it's not in one of our special angle measures, then it just ends up being a decimal. And that's it. So that is how we convert between polar and rectangular form. So in the other sections, we're going to have to do this fast. It's one of the things that it's just like assume that you know how to do it. So if you have any questions, make sure you ask in class tomorrow. Runner out.